This is a demonstration of embedded functions, a new technology from testcover.com. Embedded functions advances combinatorial test design with improved usability and automation. This demonstration shows the use of embedded functions to define and enforce constraints in a combinatorial test design service. During our development, we discovered our usability improvements enabled automated pairwise test designs to meet novel objectives. These include coverage of equivalence classes of expected results, even when they depend on more than two test factors. Verification of equivalence class boundaries depending on multiple test factors. And verification of intersecting boundaries or corners. Without embedded functions, a higher strength combinatorial design would be needed, and higher strength designs have a cost of many more test cases. The demonstration illustrates how embedded functions can improve automation, accuracy, control, and flexibility in the test design process. What is combinatorial testing? It's a way to design tests for lots of test factors at once with a small number of test cases. The test factors can be inputs for the system under test, its configuration settings, or possibly other factors. Why would we want to do this? Often there are many test factors, so many that it's impossible to test all the combinations. If there are 30 test factors, say 6 with 3 values and 24 with 2 values, there are more than 12 billion test cases. Combinatorial testing allows us to focus on a much smaller number of test factors. We can design tests that include the interactions among all the pairs or triples of factors, using far fewer test cases. In this example, there are about 2,100 pairwise interactions, and they can be verified with only 15 test cases. Our experience analyzing failures supports this approach. Most failures are caused by faults in one or two factors. Progressively fewer failures are caused by 3 or more factors. Combinatorial test designs are automated. At some point, a button is clicked and the test cases are generated, so humans don't have to work out the combinations among test factors. An analysis is required, however. At a minimum, the test factors and their values must be chosen. Complex systems require more analysis, of course. Combinatorial testing falls into the category of black box testing. Our view of the system under test is through external interfaces where we verify that it functions correctly.